Now, welcome to this lecture 27th lecture on load flow problem. I think if you all recall, we last lecture we introduced load flow studies. Now, continuing from there, today let us define what is load flow problem. All of you are aware that complex power is equal to real power injected plus reactive power injected, which is nothing but V I J I conjugate. J is the current, V is the voltage for all the n buses. J I is defined as a source current injected into the bus. So, I can always take the conjugate of both the sides, this equation you may write if you want equation number 1. So, taking the complex conjugate of equation number 1, I get this equation number 2, P I minus j q I V I conjugate j I. Now, this j I from Ohm's law, as we saw it last time, is nothing but sigma y I k V k. Current is equal to y is equal to V or V is equal to Z into J. J is the current. So, I can rewrite this equation as P I minus j q I V I conjugate, substituting this value of j I from equation 3 into equation 2, we get. What do we get? We get P I minus j q I is equal to V I star sigma k is equal to 1 to n V I k V k. Now, separating real and imaginary parts, as we must have done 1000 times in our career, since the time you have read your complex variables in algebra or in mathematics. Now, P I will be the real of this and Q I will be, since minus sign is here, we transfer this minus here. So, minus imaginary of this. I think we do not need any great intelligence to understand this. These are the two equations of real power injected into the ith bus, and this is the equation for reactive power injected into the ith bus. Now, we can express any phasor in several ways. This you must have done throughout your B.Tech, B or BSc engineering career million times. So, here I have expressed the phasor V I, that is voltage at the ith bus, in 3 different ways. This is an exponential form, this is a polar form, and this is a rectangular form. All are same. This absolute value of V I or V I magnitude, to make it ample clear, I am writing these vertical lines to differentiate it from phasor V I. So, that there is no confusion, the clarity should be there in whatever you present, because as someone has said, it is not the matter that matters, but the way of presentation. Your presentation should be crystal clear, you should not leave any doubt or ambiguity, that is a good presentation. So, we have put it as an amplitude or magnitude, same delta I becomes angle here in polar form, and same thing if you expand it cosine delta I plus j sin delta I V I, it becomes a rectangular form, A I plus j B I form, and this is the angular form, and this is your exponential form. Similarly, y I k, which is the admittance between the nodes I and k, can be expressed as magnitude and an angle. Angle is theta I k. Please remember, these thetas will be close to 90 degrees, because resistances or conductances, as the case may be, are always negligible in power systems. If they are not, then such a power system is called ill conditioned power system, which I already told you last time. And we do have ill conditioned power systems at times, and at that time you can't ignore resistance or conductance. Expanding those earlier two equations P I and Q I, which we just now seen, substituting this voltage and admittance, we get V I sigma k is equal to 1 to n, V k y I k magnitudes cosine of theta I k plus delta k minus delta I varying from 1 to n. And similarly, for reactive power we get minus V I sigma k is 1 to n V k y I k sine of theta I k plus delta k minus delta I. Now, these two equations are very important in power systems. Whatever you do in power systems, you cannot get rid of these two equations. They are called SLFE. What is SLFE? Static load flow equations. These are, as is evident, 2 n power flow equations, and this and this. P I are n equations, Q I are further n equations. So, in all we have 2 n power flow equations or load flow equations. It is used interchangeably depending on your fancy, your liking or whatever. But how many variables are there? Unfortunately, mark my word, unfortunately, variables are 4 n. What are they? P I, Q I, V I magnitudes and delta I. At each bus we have these 4 variables, and hence on n bus system we have 4 n variables. So, what is the problem? You may ask me this question. The problem is, we have been told right from our middle school stage, our teacher must have told us that as many equations, as many variables, no problem. X plus y is equal to 4, x minus y is equal to 6, you can solve this and you get explicit values of x and y. Provided if you have studied linear algebra, they are linearly independent equations. If x plus y is equal to 4 and 2x plus 2y is equal to 8, these are not 2 equations, this is same equation. You multiply the first equation by 2, you get the next equation, then they are not linearly independent. But we are talking about linearly independent set of n equations in n variables, no problem. You can use Cramer's rule, you can use matrix theory, you can use any tool and you can get the values of all the variables, because you have as many variables as many equations. Unfortunately, here the number of variables are double than the number of equations. So, to solve such a system, what we have to do? We have to assume 2 n variables, or we have to specify 2 n variables knowing our system. Since we are engineer, since we are analyst, since we are the master of our system, we know our system too well. Okay? So, I can specify, problem is familiar to me. Like when I make thermometer, I do not make from 0 Fahrenheit to 200 Fahrenheit. I know the human temperature varies between 96 degree Fahrenheit to 108 or 108, you will go straight upstairs. So, 106 like that. They do not make it at full scale, because there is a knowledge, and this is a knowledge society, knowledge based algorithms, knowledge based methods, expert system, ANN, fuzzy, neuro fuzzy and so on. You are reading it in your control courses or your other courses. So, we should know the knowledge of the system and then assume, we should be able to assume 2 n variables, so that remaining 2 n variables then can be easily solved, because we have 2 n equations anyway with us, and that is why there is a need to assume 2 n variables. SLFE can be solved for 2 n variables if remaining 2 n variables can be specified. This is what I was talking so far, and this can be done because we know our system so well. Fix a priori 2 variables at each bus, then these please remember, these equations are, what sort of equations are these? They are non-linear, but they are algebraic. There is no time here, like swing equation. All of you must have studied stability in your undergraduate. So, you know what is swing equation. Okay? d square theta upon dt square, all delta double dot is equal to, I mean P A is equal to m delta double dot. Let us put it to very simple. So, that swing equation you have to solve, means you have to go for numerical techniques and Runge-Kutta method or modified Euler method or whatever. that you will learn when you will again read stability somewhere. Here luckily there is no time. So, what it is? It is a non-linear, a set of non-linear algebraic equation. Why non-linear? There is a V squared. The cosine and sine themselves are non-linear. If you expand cosine, theta minus theta square by factorial 2 etcetera, infinite series. Similarly, sin theta is also theta minus theta cube by factorial 3 and so on. Since they are non-linear algebraic equation, you can't get a closed form solution. You understand what is closed form solution? X square is equal to 4. So, x is equal to plus minus 2. This is called closed form solution. You did not go to computer, you did not write any MATLAB program or Pascal program or any Fortran program or C plus or C++ or whatever. You simply use your knowledge and got the value x is equal to plus minus 2. This is called closed form solution. But if you are a fussy person, you can always say let x be equal to 2.1, the initial value of x, substitute, oh it is going more than 4, what is the difference? There is a difference, there is an error. So, you correct that x, okay 2.05, now error is reduced, it is converging, and depending on your convergence criterion, you may get again 2 or 2.0004 or 1 or whatever. So, that is a numerical solution for x square is equal to 4. You can also solve x square is equal to 4 numerically. You may get exact answer is equal to 2 depending on your convergence criterion, or you may get 2.0001 or something like that. So, what you do? Fix a priori two variables at each bus. Non-linear algebraic equations difficult to solve. We have to go for iterative numerical techniques. There is no other way, because we cannot solve them straight. There is no direct solution possible. There is no closed form solution possible. Hence, you have to resort to numerical solution. Depending upon which two variables you specify, the buses or nodes in power system are categorized into 3 categories. What are those 3 categories? PQ bus, PV bus, slack bus or swing bus or reference bus. So, there are 3 names given to this special category of bus. Even some experts or some books call PQ bus as a load bus, but according to me load bus is a special case of PQ bus when no generator is attached to a bus, and yet if it is a PQ bus it is called load bus. Some people call PV bus as a generator bus, but according to me a PV bus need not have a generator attached to it. You may have a capacitor bank attached to it. Whole idea is to keep V constant, and V can be made constant by so many means. The voltage control you must have studied in your undergraduate. So, you know what is static var control, you know what is facts, you know what is dynamic compensator, you know what is a synchronous motor running at no load, that is dynamic compensator or synchronous converter. There are several ways by which you can call these controllers, static controller, dynamic controller and so on. So, these are the different names though given, and if it is asked in interview you should not worry what is generator bus. Generator bus normally means PV bus, a load bus normally means PQ bus, and similarly I have written 3 names here: slack, swing, reference. There is a meaning to each name. Let us start with reference bus. Why it, and mind it is only one such bus, that is why I have written this 1 here. This 1 indicates that such a bus is only one in the whole system, whereas PQ bus is 85% of the buses are PQ buses and roughly 15% buses are PV buses. Why? normally a generator is attached to PV bus. That is all it is called generator bus. So, what do you specify at PQ bus? Pi and Qi. What is not specified? Vi and delta I. The question mark means non specified, because here in a slide you have to write minimum and you have to explain maximum. There is no point in writing each and everything, because you have a book, I am explaining and you are all intelligent people. Similarly, PV bus, what is specified? Pi and Vi. What is not specified? That is unknown. Qi, the reactive injected power, and angle at the ith bus, delta I. So, these two are two special categories, PQ bus and PV bus. 85% of the buses are PQ bus, 15% buses are the PV bus. Now, come to this one single bus. First of all, this question is always asked in an interview in UPSC, Indian Administrative Service Exam, Engineering Services Exam, NTPC exam, even GATE exam, which now you do not have to give, you have already gone through that. Why slack bus is a very important question. First thing is, you have to refer all angles at remaining buses with reference to some bus, and hence delta 1 is normally assumed to be 0, and rest of the buses are referred to this bus angles. This is without loss of any generality. You can always say 5 degrees, no harm done, but why not take 0? Now, this V 1 is also specified, normally 1.04 per unit or even 1 per unit or whatever you can specify. Why we do not know P 1 and Q 1 till the end? Because if you know P 1 and Q 1 at all the buses, then you do not have to solve load flow, that means you know the solution. And why is it necessary to leave one bus where P 1 and Q 1 are not known? Because there has to be a generator bus. Please understand, slack bus always has a generator attached to it, always, no exception here, like PV bus exception. And mind it, this generator is normally the biggest in the system, and if it is still icing on the cake, if it is centrally located. It is not a must, it is not a must condition, but it is, as I said, icing on the cake if it is centrally located. If it is a UP State Electricity Board, Singrauli superthermal power station can be considered as slack bus. Why? It is 2000 megawatt station, it is a superthermal. Superthermal is, anything called superthermal is more than 2000 megawatt. Anything which is called mega power station is more than 1000 megawatt. These are the two special categories of power stations. That is of course thermal, because hydro we have not yet crossed Bhakra, which itself is less than 1000. There are two wings of Bhakra, east, west, 6 generators each. As I told you, slack bus is there to supply SL. SL is complex losses, PL plus JQL. Partially, that is the difference between total load plus losses minus total generation. So, whatever is extra left, that will come from this slack generation. That is why anything that is slack, anything which is remaining, anything which we could not fulfill from rest of the buses will come from, suppose you need to spend 12 rupees and you have only 10 rupees. Who gives you minimum 2 rupees when you are child, a young child, small child? Your parents. So, they are slack bus for you. Okay. So, this is the meaning of slack bus. Swing means all buses swing with reference to this bus, that is called swing. So, each word has a meaning. I hope all of you have understood now why we should have a slack bus. In case anybody asks you this question, at least 11 of you should be able to answer, any one of you. However, this is known in the end only when you solve the network. So, that is all right. So, losses are the last item on the menu when you solve load flow problem. As I told you couple of minutes back, the bus connected to the largest generator is normally assumed to be or considered to be a slack bus, and it is always called either 1th bus or nth bus, just for convenience. If you are fussy, if you are a different type of person, you can always call it 20th bus, it does not matter, computer will take care of it. But for convenience, since you do not lose anything, why not call it number 1, so that you start your computations from 2 to n, mathematical convenience. Now, let us consider a general equation f of function of x comma y is equal to 0. The dimension is 2n, that you know already, because load flow equation dimensions are 2n. This consists those two equations SLFE. 2 means 2n, each equation is n, where x is always, since you have started learning, your teacher must have told you anything unknown is x. Let x be the, whatever question was asked, height of elephant, let x be the height of elephant. That since the time immemorial you must have been started learning, you must have been talking about this x as a unknown. So, x is a dependent or state vector of dimension 2n. These are in fact 2n unspecified variables or unknown variables. In your all control system, you or any system, why control system? Let it be aerospace, let it be medical system, x is always considered as a, irrespective of caste, creed, color, country, etc. Everywhere it is x, including former USSR. There is no USSR left now. They used to consider voltage as U and not V, but as far as this unknown is considered, they also used to consider it x, because they wanted to be different than America always. Since America considered V, they considered U. Anyway, what is y? Y is always a vector of independent variables. Please understand, I am not using word control variables, because independent is bigger than control. Control is a subset of independent variables. Why? You need not control anybody and everybody. Suppose there is a class and you know which two students are naughty. If you control them, you do not have to worry about the rest of the class. Similarly, here, and then mind it, control means effort, money, you have to spend money. Any control is not free, whether it is a P controller, PI controller, PID controller, fuzzy controller, whatever controller it is, you have to pay money for it. If you use that stabilizer, you have to pay money for it, it is not free. And incidentally and interestingly, not interestingly, unfortunately, in India, whatever equipment you may purchase, let it be TV, let it be PC, let it be AC, let it be fridge, that investment has to be accompanied by another investment called voltage stabilizer, because you are not sure what quality of power you are getting. So, that is again a control, you are trying to control the voltage. So, y is a vector of independent variables and they are 2n variables, and these variables are indeed specified a priori, so that we can solve this x which is 2n dimension using this which is also 2n dimension, right. Any problems so far? As I was talking, this y can be further divided into two sub vectors. u and p. U are control variables and p is a fixed parameters, and indeed some of them are uncontrollable. Like in a class when it happens, then you have to ask him politely, would you please leave, because he is uncontrollable and you can't afford to have the rest of the class suffer because of that one element. In IIT, of course, no such thing happens. As I told you, what can be U? The example of control variables: voltage at PV bus. You want to keep it fixed. How do you keep it fixed? By controlling it. If you leave it, it will vary depending on your supply, depending on load. The moment you start, say one lamp is on in your room, and if you start another lamp, you will find it goes slightly dim. You can notice this phenomena. The moment you start your AC or your fridge in your house, in hostel you do not have individually AC and fridge, you may have a cooler, I do not know, you may have a PC, but that load is not significant. But if you start a AC or a fridge, you will find that voltage gets dim, slightly dim, right. So, you have to bring it back. How do you bring it back? By controlling. Real power, you can control it. The generation power can be controlled by controlling the steam input. I do not know whether you have studied automatic generation control, which you must have studied in your undergraduate, and you must have seen that steam, if you increase the steam, power output increases. If you decrease the steam, power output decreases. And if it is a hydropower plant, what do? Gate opening. If you put in more water on the hydraulic turbine, more power generated. If you reduce, less power generated. So, you can control active power or real power generation by whatever means, let it be thermal, let it be hydro, let it be nuclear. Okay. Of course, nuclear power control is very minimal, you can't do much, and that is why it is used as a base power plant. This question is always asked in interviews, why nuclear power station is being used as a base power station, because you cannot do much, you cannot play with its generation, the rods are fixed, everything is fixed, and hence that is used as a base power plant, and there is always a base load to be catered to. Like your fellowship, you have a certain basic expenses, base expenses, you have to pay fees, you have to pay your hostel bill, mess bill, minimum other compulsory expenses. The word constraints is very important in life. Forget about electrical engineering or energy engineering or any engineering. Constraint in life, we have to face this word, we have to face this reality every moment that we live. I have a constraint of 1 hour, you have a constraint of 2 years to complete your M.Tech, you have a fellowship limited to 6,000 or whatever thousand it is, you can't just go and say make it 7,000 this month onwards. Similarly, there are constraints in electrical engineering, and there are 3 types of constraints. If you have studied optimization techniques or OR, as indeed mechanical engineering students study, even electrical engineering students study, management people, MBA people study OR. OR is operational research or optimization techniques. There are 2 types of constraints. One is equality, another is inequality. What is equality constraint? The total power generation must be equal to the total load. There is no point in generating more than required. This is an equality constraint. You get 3 hours to appear for an exam or 2 hours, like in IIT we have 2-hour major test. So, it says equality constraint. You can't say, sir, half an hour more. Teacher may give of his own if he thinks the paper is tough or lengthy, okay, 5 minutes more, but then he is giving you. You can't say, I want to stay for 1 more hour, sir. He said, get out, give me your copy, whatever you have done. In olden days, they used to write extra time taken, or that they used to cut, that question was not to be checked. very strict. If you come 5 minutes late in the class, our teachers used to tell us, you are 55 minutes early for the next class, please wait outside, even if you are 5 minutes late. Now, voltage is one of the important constraint, as I have just explained you why you have to have a fixed voltage, because all your PCs, ACs, fridge, everything, all equipment are supposed to work at a given voltage. It may be 220 volts, it may be 11 kV, it may be 400 volts, depending on that particular equipment, particular device, particular instrument, and hence voltage must be, equality constraint I already explained. Now, I have come to inequality constraint, must be within V I minimum and V I maximum. And please understand, it is a very narrow range. If I want to plot it, this is V min and this is V max, okay, and this is what normally V should be, and this range is 0.95 per unit to 1.05 per unit, that means plus minus 5%. But in India, what is the voltage variation? Plus minus infinity. What is the meaning of that? A 220 volt supply can be as low as 170 volts, can be as high as 270 volts. If you go and see 60 watt bulb, it is giving you lumens of 40 watt, because the voltage is low. Low voltage problem is very prevalent in this country. High voltage, if you want to see, you have to get up in midnight and see how bright, because most of the load is not there, people are sleeping, the industries are not there, the roads are closed, I mean people are not working. So, the voltage is very bright. Both are bad, like a blood pressure, neither high blood pressure is good nor low blood pressure is good, neither low fever is good nor high fever is good. If you get 95 degree Fahrenheit or 94 degree Fahrenheit is equally worrisome as your 104 degree Fahrenheit. Similarly, the blood pressure range is 120-80. So, if you go below 80, also problem. If you go above 120, there is a problem. Similarly, voltage should neither go below V I min nor go above V I max. It should strictly remain within this range. For that, we have a hardware, we have operating constraints, and we have so many things. Voltage control itself is a separate topic. In fact, voltage stability has become a very popular topic in power systems. People are doing PhDs in voltage security and voltage stability. Books have been written on just voltage stability. Second, delta I minus delta k should be less than or equal to delta I minus delta k max. This constraint is due to system stability requirements. All of you know the power angle curve, and this is a linear portion, this is P versus delta, and normally it operates up to 30 degrees, though maximum it can go up to 90. In fact, the maximum power occurs at delta is equal to 90 EV by x, that is a P max. But in practice it never goes beyond 30 degrees because of stability requirement, and hence delta I minus delta k should be less than or equal to delta I minus delta k max. What are the physical limitations? If you go to Badarpur, I do not know whether you have gone, you must go, whichever department you are, electrical or energy, tell your coordinator or your faculty in charge to make a trip to Badarpur or Indraprasth power station or load dispatch center in Katwara Sarai, and lot of very good controllers have been installed which you must see how they are operating, how real time operation is going on, how we can find out the frequency at Muradnagar, frequency at Mathura, frequency at Kanpur, and the power exchanges taking place. All these things are automatic, all these things are now computer controlled. So, you must go and see it. Why P is controlled? Why P is constrained? Because once you have decided a 100 megawatt generator, you cannot generate 125 megawatt out of it, at least permanently for all the time. Temporarily you can overload it. See, in a car you can go for 100 miles per hour for few minutes, but the moment the traffic comes, moment the you are not on highway or freeway, you have to control the speed. So, you can't go on 100 miles per hour ever all the time, you have to vary. So, largely the power generation will remain around 100 megawatt or slightly lower than 100 megawatt, and hence there is a PG min and PG max. Why there is a minimum? If you are at all using a generator, at least generates at minimum megawatt, otherwise why you have started? If you are using your car, you can't go at 0 kilometer per hour or 5 kilometer per hour unless until it is a marriage procession, or it is going to be Delhi of 2020, wherein all cars are going to run on roads with 5 kilometer per hour, because there will be thousands of cars, and maybe the people who are walking may have to walk on the top of the car like this. That is what the cartoon of Lakshman came sometime back, Delhi of 2020. This may not happen once the metro comes, but then that is a sort of a cartoonist way of warning people that the way you are purchasing car, every house 3 cars, 4 cars, every son has a different car, every daughter has a different car, and no pooling. So, this is what bound to happen, and no good public transport system like you have in Madras, Calcutta and Bombay. There is no good public transport system. Naturally, people take out their own vehicles, which of course has been prohibited in this IIT. So, similarly there has to be maximum as well as minimum. You can't go beyond 100 megawatt, and same thing holds good for reactive power generation. If there is a bank of capacitors or even generator, it generates a given synchronous machine. All of you must have drawn PV curves, O curves, performance chart, capability curves. So, all of you know that there is a limitation on reactive power generation. There is a minimum limit and there is a maximum limit. At PV bus, voltage has to be maintained if you want to make it controllable. So, Q source is available, then only you can maintain, as I told you. Q source may be a capacitor bank or inductor bank. I hope you all of you know what is Faraday effect. The voltage goes beyond the normal value. To bring it back, you have to use a bank of inductors. In our country, Kanpur, near Kanpur, there is a Punky station. That is the only station where there is a static VAR controller established, no other place, because it is very costly. And dynamic compensator, all of you know, that is a synchronous motor running at no load. As synchronous motor is the only motor which can give you, which can operate at lagging power factor as well as the leading power factor, whereas induction motor means always lagging power factor. Then there are transformer taps, they are also controllers. They can also control the voltage. Online transformer taps, offline transformer taps, and transformer taps are always put on the high voltage side. This question must have been asked to you in your machine laboratory for vivas or interviews. Why you keep taps on high voltage? Because high voltage winding is outside, low voltage winding is inside, and then control is smoother here. There is a phase shifting transformer also, which controls real power angle. So, Y bus becomes unsymmetric if you have a phase shifting transformer in your system. Y bus does not become unsymmetric if you have a only magnitude controlling transformer taps. Let us define now load flow problem. Specify variables 2n at all the buses, that will give you vector y. 2n SLFE solved iteratively for 2n remaining variables x, compute line flows and losses. That is all we do in load flow. Why do we compute line flows? These are important to find out whether we are fulfilling the obligations. We have a contract with Panipat. Look, we will supply you this. In fact, it is a reverse in Delhi. Everybody supplies power to Delhi, everybody supplies water to Delhi. Delhi cannot supply anything to anybody, because there are shortages everywhere. Power we get about 1000 megawatt from NREB, water we get from Haryana. So, there is a obligation from Haryana Electricity Board or NREB, they supply us power. So, that will be ascertained by knowing the line flows. Secondly, you need to know line flows for protection region. You can't have a overloading of transmission lines, otherwise security problems will be there, power system security. What are the two problems? The frequency variation also creates security problem. Frequency should not vary plus minus 0.5 hertz beyond this limit. In India, of course, it varies from 47 hertz to 53 hertz, but in rest of the world it is 49.5 to 50.5 hertz, and in US of course 59.5 to 60.5 hertz, where it is 60 hertz. Sometimes we need to conduct approximate load flow. How do you get transmission line losses computed? Add all the line flows. Having computed line flows, just add them, one more command, computer command, add all line flows. If it is 0, it is the ideal situation. If it is not 0, which is a practical situation, it gives you losses. Approximate load flow solution we need sometimes when we do planning studies. We do not have to do exact thing, what will happen in 2020, God only knows, GOK, God only knows. So, there is no point in doing accurate studies for 2020. So, we can always, for expansion sake, to decide where we should establish next power plant. So, we can do this for planning studies, offline studies and approximate load flow. And how do you solve approximate load flow? By considering resistance 0. Once you say resistance 0, losses are also 0. The losses are there because of R. If resistance is not there, no losses, I squared R. And these thetas will also become 90 degree or minus 90 degree once resistance goes, because R, X, Z. There is no R, is only X. So, it is only 90 degrees. And sine of delta I minus delta k becomes delta I minus delta k, because delta is small. What is sine 30? 0.866 root 3 by 2. Sine 0 is 0. So, it varies from 0 to 0.866. So, you can always say the angle and sine are same when delta is small, and delta is indeed small. We always operate on a linear zone. Let us also assume all buses are PV buses. There is no PQ bus. If you assume that, what is the advantage? All voltages are known. Once you say PV means what? V is specified. That means your non-linear equations SLFE get reduced to linear equations. All voltages are known, sine cosine gone. So, what is left? Only deltas. And this equation will give you the values of delta, which then you substitute here, you get value of Q. So, a set of linear algebraic equation in delta I only, voltages are not unknowns, and hence we can solve them by ordinary closed form solution. Cramer's rule, those determinants and all those things. And once we know that, then P1 is known to us anyway, because all PDI is known, all PGI is known. So, P1 is also known, because losses are not there. Earlier, why they were not known? Because losses were not known, and losses we used to know in the end, and hence P1 we used to know in the end. Now, there is no such problem. Computationally, it is very economical. Please solve, this is a take home exercise, not take home test. In US they give take home test, and they believe the students, and whatever a student submits they get marks on that basis. Here somehow we have no faith on each other, and hence take home tests are not given in India, because it is assumed that one fellow will solve it, rest will do it xeroxing. That is what happens in assignments. But I do not mind even if he understands and copies it. Unfortunately, what happens, he gets xerox, he does not want to understand even, and that is what creates problem in India. So, please solve 6.3 example, which is already a solved example. You have to only read. How do you solve a solved example? This is also an art. Do not read it like India Today or Film Fair or whatever. Read the language of the problem, close the book, solve it yourself. The advantage is in solved problem, you will exactly pinpoint where you have gone wrong, assuming that the author is correct. That is a big assumption. There are books in India where nobody knows who is correct. Tharejas and Soni Gupta Bhatnagars and Mehtas, there are so many books where God only knows what is correct and what is not correct. But if the book is standard, and if you know that the book is not wrong, then you can find out where you have gone wrong, which is not a facility available in unsolved problem, because they are only answer. If you get an answer, then you can feel satisfied. Sometimes even if you get an answer, the method can be wrong. I will give you an example. (64 by 16), answer is 4. If you just cut 6 and 6 and get 4, this is wrong. So, even if you get a correct answer, there is no guarantee that you have done correctly. You might have made 2 mistakes which will cancel each other, and still you may get a correct answer. And that is why, and this is true for any course till you appear in exam in your life, which will not be now long, because you will have to stop. PhDs you do not have to appear in coursework, barring 2 courses. So, this may be your last year of appearing in exam and so on, university exams, that is. So, that is where the solved example helps you in building confidence. So, do not just read it, but close the book, try to solve it and see whether you can get the final answer. So, example 6.3, please try it at home. I assume that all of you have books. Now, we come to one of the methods that we adopt for solving load flow problems. Approximate solution, you will do it at home, that problem. There is a Gauss method. Okay. But what is the Gauss method and Gauss-Seidel method? What is the similarity? The Seidel is another person who modified Gauss method. What they used to do in Gauss method, they never used to update till the end. That will used to take more time in convergence. What does this Gauss-Seidel method does? Suppose you calculate x1. So, while calculating x2, it uses this latest value of x1 rather than earlier assumed values of x1, x2, x3, xn. So, this will definitely hasten the convergence process, and that is the only difference between Gauss and Gauss-Seidel method. I do not think I want to start this method today. So, I will start it on next Tuesday, which will be what? Today is 24th of August. So, gentlemen, we will meet hopefully on 24th of August, same studio, time is not same, that is 12 to 1. Any questions you have in this lecture, whatever we have done today? I assume that when you go back home, you do read what is given in book. Even if you have done this topic earlier, it is nice to revise it, so that it gets perfected. And in case some of you become teachers, because teachers now there are a lot of vacancies, so you may have to also teach similar topic or any topic. So, any questions, any doubts in today's lecture? In that case, if not, then thank you very much.